Okay, so the next topic is domain class relationships. Sometimes we call relationship as association, so both terms are fine. Either one is fine. So this is what we are going to talk about. So we will talk about what domain class relationship is. And the most important relationship type is cardinality relationship. One-to-one, one-to-many, many-to-many. So we're going to spend some time learning how this cardinality relationship works out. And we will see cascading update, cascading delete, and cascading save. And we'll talk about eager and lazy fetching. And we'll talk about composition relationship and inheritance relationship as well. Okay, so domain class relationships. So what is a relationship? So relationship define how domain classes interact with each other. There are actually several types of relationships. Cardinality relationship, as I said before, one-to-one, one-to-many, many-to-many. Directional relationship and inheritance relationship, as well as in a composition relationship as well. So impact of relationship. So depending on how you are going to relate your domain classes to each other, the persistence behavior might be different. For example, cascading save and delete, locking, and performance will have some implication as well. Because the fetching strategy might be different depending on how things are related. Same thing with the caching. And table construction might be different depending on what inheritance strategy that you choose. So we can actually talk about these things in a bit more detail in the rest of the presentation. So how does relationship is represented in Grails? So in Grails, relationships are represented through a set of static properties in domain class. Okay, so examples are like this. I have a class, the project domain class, and it has project name property. Now we have relationships between this project domain class to other classes. So here has one. So this has one means project has one project manager. Okay, and this project belongs to portfolio. And this project has many milestones and many members. Okay, so you can in fact have a multiple the domains as a relationship here. Okay, so why do you want to use a relationships? Relationships result in compact code. So by specifying this relationship, you are asking the GORM to do a lot of heavy lifting for you. So you don't have to do this relationship handling yourself. Okay. Good example is cascading save and delete. Okay. So whenever you set things up correctly, when you save parent, so example is like this. Suppose we have a car object, and car has many parts. Okay, so car has one-to-many relationship with parts, and parts belongs to car in this case. So what you want to do is whenever you are saving a car, you want to save associated parts. Okay, so that's cascading save. And whenever you delete a car object, you want to delete the associated parts as well. So that's cascading delete. Okay. So as you will see later on, this the cascading save and delete could be specified using what is called the belongs to relationship. Okay. So we'll talk about that. So let's start with the one-to-one relationship first. So directionality and navigation first. So one-to-one could be bidirectional or unidirectional. So directionality affects the navigation. So if customer and address has one-to-one relationship, you can actually access from customer to address. But if you cannot access customer from address, that's a one unidirectional relationship. Okay, what it means is that in this address domain class, there is no field of customer. Okay, same thing for one-to-many. So if a customer has many orders, So customer can access many orders. However, if you cannot go from order to customer, then that's considered as one direction. Speaker and events, yeah, it's actually many-to-many relationship, the same thing. So if you can access events from speaker, then however, if you cannot access speakers from event, that's a one direction, unidirection. Bidirection, of course, is actually you can access either direction. Now, let's talk about the concept of ownership. So, relationship, there is an aspect of ownership. And who owns a relationship affects how objects are persisted. Okay? So, in fact, the owner can do the cascading persistence, meaning owner can do cascading save and cascading delete. However, owned, the other side, cannot. Okay? And the way that you can specify who is the owner is actually owned will actually use belongs to relationship to the owner. Okay, so let's see an example in one-to-one case. Okay, so in one-to-one cardinality, you are going to use a belong to here. So we have a student domain class and address domain class. Okay, so this is a bidirectional because from student you can access address, and from address you can actually access the student. By the way, when you say belongs to and student, it's actually creating a property. It's creating a field of the student whose type is student. Okay, this one doesn't have to be same as this one. It just happens to be property name. Okay, so address has a property of student, so they are in fact bidirectional. Now, in this case, address says I'm belonging to the students, which indicates that student is the owner. What that means is that owner can do cascading save and delete, but owned, in this case, address cannot. So that's what this is all about. So I could actually create the new address and then set into address field of student, and then I can actually do save on student. So at this point, it will do cascading save, meaning it will save student object as well as address object. However, the other side, from the owned, it will cause an error. So I cannot actually add student object here to address, and then I cannot actually do address and save. So this is not allowed. Okay, meaning the cascading save and delete is allowed only from owner direction. In this case, from student to the address direction. Now, in one-to-one case, you can also use has one. So has one, in fact, has this ownership relationship, the kind of built in. So when student has one, that means student is in fact the owner. So you can use either. And either will actually support cascading save and delete. All right, so let's do exercise 1. One-to-one mapping. So we are going to create a new Grails application, and then we're going to create domain classes with one-to-one mapping, and then we're going to create the controller and add a method. So in this case, we're going to add create student method, and we're going to actually see whether cascading works or not. Okay. All right, and lastly, we're going to try the has one as well. So we are going to create a relationships app, which I have done that already. Okay. And then we are going to create a domain class student. Okay, so this is when you're using Eclipse, and we're gonna add student class as well. So here student, the student has address field, right? Okay, and then we're gonna actually add domain class. Okay, so in this domain student domain, the address domain class, we says belongs to student. What it means is that we are making student as the owner of this relationship, which means student can do cascading save and delete, but address cannot do cascading save and delete because address is owned, and while student is owner. Okay. All right, so we save the change, and then we create controller. So we create the controller, student controller. So inside the student controller, we are going to add this create student method. Okay, so here we are going to create a new address object, and then we are going to add that address object as a named parameter here. So we create a student. Now I can save the student, and it will do cascading save. Okay, which means it will save not only the student but also the address. That's the cascading save. Okay, and we're going to run the application. And then we are going to create a student, and then we're going to see, whether cascading save has been successful by looking at the database. So let's do that. So I have already created everything, including the controller and the create student action method. Okay, and let's take a look at the address. Okay, so address belongs to student, and student has an address here. So student is an owner. Okay, so let's run this relation. Let me make sure that nobody is running at this point. Okay, so let's run this relationship application. And then we are going to invoke create student, the action method. Okay. Okay, so that is done. So I'm gonna just click this link. Okay. Why it doesn't? Okay, let me try one more time. Let's make sure that this guy is up and running. Okay, so why is actually, so I'm gonna just call it the student, create student. Okay, so that worked. Okay, so so now it says a Sang Shin and who live in New York City has been created. So now I'm gonna actually take a look at the database, DB console. Oh, not this one. I have to go from the application context. So we're going to verify student object, student record has been created, as well as address has been created. So we're going to take a look at the student first. Okay, and I click student and then click run. Then I see Sang Shin has been added. Okay, now if I actually try to add, okay, now yeah, so whenever you actually, without clearing it, if you try to run it, you will have this the syntax error. So make sure you clear first. And now let's take a look at the address and then run it. And now I can see address is also persisted. So this is a cascading save. Okay. All right. So now let's take a look at the delete. So we actually have done the DB console. I just to show you. And we're going to actually add this delete student. Okay, so here the reason it didn't work is actually in my case, actually my application is a relation underscore app rather than relationships. Okay, so that's the reason. Okay, all right. Okay, so we have also added delete student. Okay, so we want to actually verify whether cascading delete works. Okay, so I'm gonna click this one and I'm gonna just remove S. Okay, so let's say delete, and I'm gonna just remove this one as S because that's actually my application. Okay, so student Sang Shin has been deleted. Now I'm gonna actually take a look at the again DB console from here and connect and see student. There is no student, which is good. And let's see whether address is also deleted. Okay, so let's clear and click address and run. And there is no address on the address table either, which means cascading delete worked. Okay, all right. Okay, so that's exercise 1. All right, so now let's try to use has one. So has one is something very simple. Has one is another syntax. Okay, So instead of using belongs to in the owned class, I want to actually have it a little more clear, the syntax. So here I'm going to use has one in the owner side, and then in the owned side, I'm going to just have property. Okay. So let's change from student. We are going to use this guy. So basically, I'm not using this one, but using has one. And address, we are going to use, instead of belongs to, I'm going to just have a property. Okay, and save. And we might have to restart it because we actually changed the domain class. So let me just restart it again. And it's going to be the same behavior as you have seen in the belongs to case, the cascading save and cascading the delete works. Okay. All right. So here I'm going to just click this one and remove as. Oh, I didn't remove it. Oops. Create student. Okay, so Sang Shin has been created. And again, let's take a look at the DB console and see whether we have both student and address. Let's clear this one first. And address is created. So cascading save has been working with has one as well. Okay. All right. So that's a one-to-one relationship. Now let's move on to one-to-many relationship. So one-to-many relationship, you are going to specify has many in one direction in the owner side, and in the owned side, you are going to say belongs to. Okay. So when you say has many with the books, basically you are asking, I want to create a properties of books in this domain class and whose type is a book. Okay. And here I'm also saying that book is owned by the author. So again, cascading save and delete will work from author side, but not from book side. Okay. All right, so let's do exercise 2. So here we're going to actually create author and the book domain class. Okay, so let's create the author new domain class and JPassion author finish, and we are going to copy this code. So basically author as a name and age, and then has many relationship with book. Okay, and let's create a book. Finish. And then we are going to copy this code. It has a belongs to relationship to author. Okay, let's save them all. And we are going to actually have, the CRUD-based operation, see whether these relationships are actually working correctly. Okay, so we are going to actually do scaffolding. So let's create the controller. New controller. JPassion and author. And we're going to say scaffold true. and we are going to create the book controller, new controller, JPassion book controller, and again we're going to do scaffolding, dynamic scaffolding, and we save all the changes. Okay, and now we're going to actually perform because we have created new domain classes, we might have to actually restart. Okay, so let's just restart it. And we're going to create the new author. Okay, and when you click the new author, what you're going to actually see is you can actually have add book here, because the Grails knows that there is one-to-many relationship. So we can click add book here, or you can add the edit and add books. Yeah. So we'll actually add a few books and authors. Okay, doesn't have to be exactly like this. Okay, all right. So we're gonna actually do this, and we are going to go author, and let's add a new author. John, age 22, and we can certainly add books right here. So we can add books, book 1, and we'll just say, and here, oh yeah, we have to create an author first, because this one there is no author, so we have to actually create an author first. So let's create author John, and then we can edit, and here we can add books, and now we can choose John, and book 1, create, and let's create the we can actually go to books, and we can actually create a new book as well. Book 2, yeah, you can choose John here. Okay, and let's create another author. Go to home, author, and new author, and Mary. Age is 1, and create, and edit. Yeah, we can add books at that point, but yeah, we'll just add book 3. Okay, great. Okay, so if you take a look at the author list, so if you go author, and you can see author has John and Mary, and if you click John, you can see John has book 1 and 2, and Mary has book 3. Okay, all right. Okay, so basically we are actually experimenting with one-to-many relationship between one-to-many using CRUD-based scaffolding UI. Okay. So now we're going to actually add a new method to author. So again, this is going to actually verify whether cascading save works. So here we are going to add books to existing author. Okay, so existing author in this case is Sang Shin, so I have to change this one. So I'm gonna find the author. Okay, and then I'm going to add 2 new books. Okay, Life is Good and Yes Indeed, books to this author. And yeah, so I'm gonna just add 2 books to the existing author. So I'm gonna just copy this code, and then I'm gonna change the name from Sang Shin to John. Copy this guy, and author controller, and here, and it's to be John. Okay, save the changes, and then let's go to we'll just go to here, and Okay, so adding books to existing author has been successful. So now let's take a look at the DB console, see whether things are really added. Okay, DB console and connect it. And now let's take a look at the author. And we have two authors, John and Mary. Okay. Oh, what happened? I need to see. Oh, okay. Yeah, we're actually adding books to existing the authors. So there is no new author. But what we need to verify is whether books actually have been added. Clear. Book. Run. Now you can see these two books actually have been added. Okay. Yeah. So this is not really verifying the cascading save because we are just adding books to existing existing author. Okay. All right, so that has been successful. Now we just verified from the DB console. Now we are going to delete the author. Yeah, so delete author will actually verify whether cascading delete is in fact working. So I'm going to copy this code, and we are going to add here. And I'm gonna change it to John. So if the cascading delete worked, then all the books that is authored by John should be removed, right? Okay, save the change. Now let's actually, so we'll actually do delete. Okay, so author John was deleted. So let's take a look at the DB console. And let's see the books. So you can see only books that is actually remaining is the book owned by the author Mary, because if we go to the author, we have only Mary. Okay, and Mary has just one book. So you can see cascading delete worked. Okay, all right. Okay, so that is that. All right, so let's move on to the next. Next is many-to-many. Many-to-many relationship is a little bit more complex than one-to-many because it can be represented in two different ways. Okay, and you have to actually choose depending on your application's need. Okay, so option one. You do not choose to create third domain class, okay? And then you define has many on both sides of the relationship to each other, and then you specify belongs to on the owned side, okay? Which make the other side as owner, okay? Option two is you are going to create third domain class, and then define has many on both sides of the relationship to this newly created third domain class, and then define belongs to the third domain class. Okay, so you might think, what the hell are you talking about, right? So let's see an example, and we'll actually see which option you want to use. Okay. All right, so this is option one. So let's say we have a many-to-many relationship between student and teacher, meaning student go to many teachers and teacher has many students. Okay. So here, both student and teacher will have has many relationship to each other. Okay, so student has many teachers, and teacher has many students. Now, in one of these domain classes, you can specify belongs to. Okay, so it indicates who is. But but you can see it's not really belongs to with this format, right? So it's actually belongs to just teacher. Okay, it indicates who is allowed to do cascading save. Okay, so actually cascading delete is not allowed. Okay, but cascading save is allowed. Okay, so in this case, because the student make teacher as owner because it says belongs to, teacher is the owner, meaning teacher can do cascading save. So whenever teacher is saved, associated student object will be also saved. Okay, but cascading delete will not work because you do not want to delete students just because a particular teacher is deleted, because that students, those students might belong to other teachers. Okay, so I have to actually remove this. So I have to say just a save here. Okay, so this is the cascading relationship. So as I said before, from the teacher you can add students, and when you say save, this will work, okay, because the teacher is the owner and owner can do cascading save. Okay, however, if you try to do the same thing from the student side, student is the owned, right, it will not work. Okay, in fact it will only save students, not the teachers. Okay, all right, anyway, this is option one. Excuse me. This is option one, where you do not have a third party, the domain class. Okay. Okay, so let's do this exercise, exercise 3. So this is the many-to-many relationship option number 1. Okay. So without using join entity. By the way, that third party domain class is called a join entity sometimes. Okay. Okay, so we are going to create. Yeah, looks like I wish I have. Okay, so it's the same application. Okay, so I'm gonna create the speaker domain class. New JPassion dot speaker. And then we are going to have has many relationship with conferences. So this is a speaker versus conferences relationship. Since we have not created conference, we have a compile error here, so we have to create a conferences conference domain class. New domain class conference and finish. And we are going to have conference class. Now it has many relationship to speakers. Okay, but since we have said that belongs to conference, conference is the owner. Okay. Okay, so now we are going to create the speaker and conference controller, and again we are going to do dynamic scaffolding. Speaker controller. So I can say it like this: speaker, new controller, and finish. And scaffolding true. Same thing for the conference. Right click, new controller, and we are going to scaffold. And we save them all. All right, now we are going to do some CRUD-based, so we are going to create the speaker, and we are going to, we're going to actually have 3 speakers, okay, and then we are going to add some conferences, and for some conferences we'll actually select the speakers and things like that, okay. All right, so I'm gonna just use this guy. Let's go to over here. Okay, so I'm going to go speakers. Oops. Why it doesn't work? Conferences. Oh, did I save everything? I did. Scaffold true. Speaker scaffold. Circumference. And speaker. And we did conference. Scaffold true. Speaker. Scaffold true. So what's the problem? No signature method of JPassion conference list. Yeah, looks correctly to me. Conference, okay. Okay. All right, so here. All right, so let's actually try to add speakers. Okay, so that worked. Okay. Yeah, so I didn't restart the application. All right, so I say speaker one, specialty Groovy, and create. And I'm going to create a new speaker. Speaker 2, specialty Grails, and create. And all right, so and then we're gonna actually go to add conferences, new conference, conference name JPassion, city Lexington, Boston, and yeah, so I can choose speaker 1 for this. Okay, and let's actually choose the speaker 2. Update. So JPassion has a speaker 1 and 2. So let's actually create the another conference. Go to new conference and Java 1 and San Francisco, and we'll have speaker 2. Okay. All right, so we have enough the data. Okay, so when we actually go to DB console, we should actually see these conferences. Okay. Same thing for the speakers. Okay. And so now you can actually see the join table. So let's actually see the join table here. So regardless which option you use, many-to-many relationship will have underneath in the table, will have a third table called the join table. Okay. So let's take a look at the DB console, and connect. And you can see there is actually a join table called the conference and speaker. Okay, so you can see this is conference ID and this is a speaker ID. Okay, so that's a join table. Okay, and now we're going to add some the method to conference controller. So here what we're going to do is we are going to create. We are going to actually we are actually adding new speakers to the to the existing conference. Okay, and um, and then we're adding new speakers to the existing. Yeah, so I should actually kind of modify this code, in order to actually verify cascading save. I want to actually create a new conferences. But it looks like I was actually using old. Okay. But delete, you can see the delete. Yeah, delete is not actually kind of verifying the cascading delete, because you cannot do cascading delete in many-to-many relationship. Okay. All right. So I might actually kind of change this code. So let me just copy the whole thing, and I might actually change the code so that I'm going to actually create a brand new conference. Okay. So say copy this guy, and controller. So the controller, this is the conference controller. So from the conference controller, I can do cascading save. Okay. But you cannot do the same thing from the speaker side. Okay. Okay, so I'm gonna actually create a new conference here. new conference. Instead of this, I'm going to say new conference. And the conference has conference name and city location. Conference name is whatever conference, and city location is New York, like this. Okay, so I actually create a new conference, and then I'm actually adding two speakers, Sang Shin 1 and Sang Shin 2, and let's see whether that works. Okay, oops, yeah, that's good. And then I'm going to call this guy. Okay, and again, I'm gonna remove S here. Okay, so adding speaker to existing conference has been successful. Yeah, so the comment is wrong, but we are gonna actually find out whether the Sang Shin and Sang Shin 2 has been added to the new speaker, the whatever speaker. Okay, so we're gonna actually see whether cascading save has worked. Okay, DB console. And here, let's take a look at the speaker conference first. Okay. Okay, so whatever conference has been added. Now let's see the speaker. Oh, speaker has not been added. That's not good. Oh, here we go. Okay, so Sang Shin 1 and Sang Shin 2 has been added. Okay, so cascading save worked. Okay. All right, so that is that. Now if I try to delete, okay, if I go to if I to delete, let's actually try to delete the conference and yeah, so I can, so here the conference I'm gonna actually delete is whatever. Whatever. Save the change, and let's try to delete conference. Okay, so conference whatever has been deleted. So if I actually go to now this time DB console, I should say the conference whatever has been deleted. Okay, so there is no whatever conference anymore, but the speaker still should be there. Okay, speaker. Okay, so Sang Shin 1 and Sang Shin 2 are still there, so those are not supposed to be deleted. Okay. All right, so let's see, where are we? So we have done that. Yeah, so that's basically what we just did. Okay, so let's move on to the next. So now we're going to actually take a look at the second option, creating third-party model or domain class. So we are basically creating what is called the join model, or and it does have its own table called the join table that reflects the many-to-many relationship. Okay, so in this case, we are going to have a registration, model, join model, and here this join model belongs to conference and speaker. Okay, and now take a look at this. This registration has its own properties, like a year of speech. Okay, and then speaker and conference both has many relationship to registrations rather than the other side. Okay, so you can see we have 3 different domain class. Okay, and this domain class is its own property, and these two actually have has many relationship to this third-party domain class. Okay, while this guy has the belongs to relationship. Okay. All right, so let's do exercise 4. So here we're going to actually create a domain, registration join entity domain class. Okay, so we are going to create registration domain class. and we are going to copy this code. Okay. Now we're going to modify speaker domain class so that we're going to remove this one, but we'll have a has many to be registrations. Okay, so I'm going to just copy the whole thing. Speaker. And the same thing for conferences. So for conferences, we are going to do the same. And save them all. Okay. And then we're going to actually create the registration scaffolding, the controller class, and we'll do the scaffolding as well. Okay. So registration is a genuine domain class. Okay. So we are going to new controller and registration and scaffold true. Okay, save them all, and we have to, the stopped and restart because we added domain class. Okay, so we're gonna restart the application. And let's see. Yeah, so we're gonna actually again create the several conferences and the add several speakers. Okay, and then we're gonna add registration. Okay, so registration is the name. Okay, so when you do the registration, you can select which conference and which speaker and then year of speech. Okay, and we can create a few more registrations. Okay, and then we'll actually verify. All right, so let's try that. So here we are gonna go to the speaker, new speaker, speaker 1. And we're gonna create the speaker 2, speaker 2 specialty Grails, and create. And let's try to create some conferences. New conference, and conf1, whatever, and create. And we're gonna create the new conference, conf2, whatever, and create. Okay. Now, we can certainly add the registration, from the speaker and conferences, but we can actually create the registration right here, like a new registration. And you can see I can select which conference and which speaker. Okay, and year of speech like this, and I create. Okay, so let's take a look at the what has been created underneath. So DB console and connect. And so I can actually see conference, and so city location, conference name, and speaker speaker 1, and these are speakers. Now you're gonna actually see registration here. So if so clear and registration, and I can see registration has its own properties like ID, version, and year of speech property, and then it has the foreign key to conference and speaker. Okay. All right. So that's how that worked. Okay. So that is what we just have done. Here we're going to actually add another method to registration controller. So we are going to create registration. So now we're gonna create the So let me just copy this code and explain it. Why don't I explain it first? So here we are creating registration. So we create the brand new conference, and and then we save the conference, and then we create a new speaker, and we save the speaker, and then we create a brand new registration from these two conference and the speaker combination and save. Okay, so that's basically what we do. Yeah, so creating a new registration. Okay, this is a registration controller. Okay, and save. Now let's see whether create registration worked. Okay, so I'm gonna click this one and remove this S. Okay, so creating new registration has been successful. So if I go to DB console, I assume it should actually have the correct information. So let's just take a look at the yeah. All right, so we can certainly try. Oh, this is lab documentation. Okay, so I assume that things worked, and we'll just move on. Okay, so the next topic is fetching strategy. Oh, so before we move on, let's talk about which one to use, option 1 and option 2. So as you see, the difference between option 1 and option 2 is that in option 2, you create third domain model, okay, domain class. This is actually useful when you need to keep track of the relationship information between these two. So for example, the speaker, when speaker speak in particular conference, the year of the speaker, year of the speech, that's actually useful information, right? So that information can be actually maintained in a domain model in this case, okay? The registration domain model, okay? So, so when you have a need to work with a relationship model, like a registration information, then you want to use option 2, okay? Use option 1 when working with a legacy schemas or when you never work directly with the relationship information itself, meaning you don't need to keep track of the year of speech kind of information. Okay. All right. So that is that. Now let's move on to eager and lazy fetching. So fetching strategy is a strategy that any OR mapper use for retrieving associated the objects. For example, if there is a one-to-many relationship between teacher and students, okay? So when you retrieve teacher object, the question is you want to retrieve all the students of the teacher or not, okay? So that is a fetching strategy that you want to decide, okay? Deciding how, selecting a particular fetching strategy will have a performance impact, okay? Because it will actually determine the number of select statements that need to be executed, okay? Depending on what fetching strategy you use. In fact, if you're not careful, you are going to see this infamous n+1 select problem, okay? So, if you want to, if you want to learn this n+1 select problem, I recommend you to take a look at the my Hibernate join fetch presentation and hands-on lab, and we actually exercise this n+1 select problem in many different angles. Okay. All right. So relationships in GORM are by default lazy fetching, especially one-to-many relationship. Okay, I believe one-to-one is, I think, the eager fetch, but one-to-many is definitely a lazy fetch. So lazy fetching is that collection is fetched when the application invokes an operation upon that collection. Meaning, in lazy fetching, in one-to-many relationship, and let's say teacher and students, right? And the students will not be fetched until the students are in fact accessed. That's the lazy fetching. Okay, so eager fetching is it will actually retrieve students regardless whether that is actually being used or not, okay, at the beginning when the teacher is being fetched. Eager fetching strategy or lazy fetching strategy is declared in the domain class, okay? So as a default, I think the lazy fetching is the default. For eager fetching, if you want eager fetching, then you have to specify it. Yeah, so this is the case. So let's say we have one-to-many relationship between author and books, right? Here has many. And if you want to turn off the lazy fetching, then you can say mapping books lazy false. Okay, so it will do eager fetching in this case. Okay, what it means is that the books will be loaded at the same time as the author. When the author is accessed, the books will be also fetched. Okay, the problem of this eager fetching is that if a particular author has 10,000 books, right, and you might in fact actually retrieve 10,000 records from the database, whether you use it or not. So that's the reason lazy fetching is usually a good practice. Okay. Now you can also use a batch fetching here. So instead of the either choosing lazy fetching or eager fetching, you can use a batch fetching. Batch fetching is that when author is actually accessed, it will try to fetch just 10 books rather than 10,000. Okay, so it's sort of the middle ground. All right, so let's do exercise 5. So here we are going to configure data source Groovy. What you want to do is we want to actually see SQL commands being executed. Okay, so we want to see how many select statements are being executed. Okay, so let's go to data source. Let me just conf and data source here, and we are going to set log SQL true. Okay, so it will display all the SQL statements that are being executed. Okay, and then we are going to we're going to actually add some test data into to Bootstrap Groovy file. Okay, so config bootstrap here, and I'm gonna just copy the whole thing. Okay, so here basically we are creating new author 1, and author 1 has 3 books. Books 1, 1, 2, 1, 3. And author 2 has 1 book, and author 3 has a single book called the 3.1. Okay, so we save them all as a test data, and then we are going to add 2 methods to the author controller. So author controller, and what we want to add is basically these 2 methods. We are going to access just author. Okay, and then this one we are going to access author and books. So in this case, when you invoke the access author only, it will do just one select statement to the author. Okay, however, if I do these things, okay, it will actually perform another other selects to access the books. Okay, so that's basically the idea. We'll actually see how many select statements are being executed. Okay, so here, okay, save all the changes, and since we changed the bootstrap.groovy file, we have to restart. Okay, and then we are going to we are going to access author only. So when you do the author 1, you are going to see just a single statement. Okay, however, if you do access author and books, you are going to, at that point, you're going to actually see this is author, and then this is the books. Okay, and that's lazy fetching, because the books will be fetched only when books are accessed. Okay, so that is the idea. So let's actually try that. So I'm gonna just run this access auth only. Yeah, actually I'm just copy this one and we'll do. Okay, so author only is access. So you can see now we have one single select statement in this console. Okay, right? Now we are going to access not only the author but also uh, the the access author and books, right? So here I'm gonna say access author and books. Okay, so this time you are going to see this. You're gonna actually see this because this is actually from previous. Now we are actually seeing the select statement, getting books. Okay, all right. So that is that. So that's lazy fetching. Now let's take a look at the eager fetching. So we are going to actually change the author domain class to use the eager fetching. So we're going to actually set books lazy false. Okay, so I'm going to copy this guy and let's change author. Okay, save the change. Okay, and we want to restart the application because we changed the domain class. And now let's rerun the application. Now this time when you try to access the author, you can see it's actually selecting, it's actually getting the books as well. Okay, so this is a join statement. So yeah. So you see it's actually getting the books. Okay, and the author books and is actually the same thing. Okay, yeah. So let's try that. So it's up and running. Okay, good. So we're gonna go over here. And what we want to do is, what we want to verify is access author only. Okay, and see whether it's actually creating select statements of getting books. Yes, you can see it's actually doing another select statement for getting books. Okay, so that is verification of lazy fetching and the eager fetching. Now let's take a look at the n plus select problem. Okay, so here what we're going to do is we're going to actually modify so we are going to actually modify the book controller, and it's going to add two actions. The first access is only book, while the second access books and their authors. So this is the killer. So this is the killer in which whenever you got the books and trying to get the author of each book, that each of those book will actually perform another select statement. That's famous n plus one select problem. Okay, so let's copy this book controller. This is book controller, right? Yeah, book controller. And book controller. Okay, so we save this thing's book controller, and now we are going to access this guy. Okay, so this time you're gonna actually see it's actually doing just one single select statement. Okay, that's fine because it's just the access books only. But if you try to access the author from books, that's basically what this is all about. So the now we are going to do access book and authors. Okay, so yes, books and authors. Okay. Books and authors. Oops. Okay, so now what you're seeing is that we are actually seeing the all the 7 actually select statement. Okay, so this is actually a problem for each book. For each book, whenever it's trying to get the author, it actually has to perform select statement. Okay, so if you're talking about, in this case, we're actually talking about small number of books. But if you're talking about a million books, then this n+1 problem is going to be a serious performance problem. Okay. All right. So that is just a simple exercise of n+1 issues. Okay. So now let's move on to inheritance. Composition relationship. So instead of mapping classes onto separate table, as we have seen in cardinality relationship, in composition, an address can be embedded in a current table. So in this case, if you say static embedded, then in this case, the fields of number and code will be in a single table of person. Okay, so that's composition. All right, so let's move on to inheritance relationship. GOM supports 2 inheritance mapping strategies. One is called the single table per class hierarchy, and the second option is joined subclass, or the class per subclass. Okay, so a single table strategy is a default, meaning all the class in a hierarchy are mapped in the single table. Okay, and the root table have a discriminator column called class, and whose value identifies the specific subclass to which the instance represented by row belongs. I'm going to explain what this means. So in the root table, we'll actually have a field that indicates which subclass a particular row belongs to. That's basically what he's talking about. Join subclass is that its parent class is represented by a single common table, but each child class will have its own table that contains fields specific to that child class. Okay, so let's see examples of this. So let's create, suppose we have a payment class, okay, and then we have the credit card payment class extends payment parent class, and we also have a PayPal payment class, which is the child class of a payment. Now here we are actually using table per hierarchy false. What that means is that we are using non-default value. Okay, which means that we are actually using the table per subclass, the strategy, or the join subclass strategy. Okay, so we'll see how that works. So inheritance enables polymorphic queries. So suppose you have a payment, and so this is the relationship we just talked about, right? And when you say payment colon list, then it will actually give all the items, including the its child classes. Okay, the same thing with this. All right, so let's see exercise 6, which is inheritance. So this is a single table per hierarchy strategy, which is a default, and then we're going to actually take a look at the join table, join subclass, or the table per subclass strategy. Okay, so here we are going to create the payment domain class. So let's create the payment domain class. Payment domain class, and then we are going to have this amount property of payment. So we'll just copy them all, and then we're going to create the create card payment domain class, which extends payment. Okay, so here we are going to create another domain class, and credit card payment, and this extends payment class. And we'll create another payment class called the PayPal payment domain class. finish, and we are going to copy this guy. So PayPal payment class, also a child class of payment class. Okay, and we save them all. And then we're going to create a payment controller, and then we are going to add this method. Okay, so let's create the payment controller, and I'll explain the code. New controller, JPassion payment controller. Okay, so basically what we do is that we create payments. We create a payment object and save, and then we create the child object. So this is creating credit card payment. Then we create the payment object and save, and then we create another payment object and save. Okay, and and we'll actually take a look at how things are actually structured, and then we are going to list all the payments. So we are actually performing query operation, and it will do polymorphic query. Okay, so let's copy this code to payment controller. Okay, and save, and we'll restart the application. Okay, so we added domain class. So we're going to actually call this create payments logic. Okay, so all right, so create payments is called. Okay, now what we want to do is we want to take a look at the database and how things are structured. As you will see, we are going to have a single table. So let's actually see that. DB console. Okay, and we see a single table called the payment. So now you can see we have each entry has, this one is from the payment class, this is from the PayPal payment class, this is from the PayPal payment class, and then you see this is a null, right? Okay, and the credit card number is null, and so this class column is indicating whose subclass this particular row belongs to. Okay, yeah, I don't know why the credit card object is not created. Credit card. Yeah, somehow this one didn't get created. Okay, maybe did I actually have a right domain class? Credit card. Oh, I didn't actually have that. Okay, that's why. All right. So the yeah, I didn't actually write the correct code. Okay. So but at least the payment, PayPal payment actually worked. Okay, so you can see it's a single table for all the classes in that hierarchy, and this class column will indicate which subclass each row belongs to. And the downside of this strategy is that you might in fact have a lot of null fields. Okay, all right. Okay, so that is that. And we can add a list some payments a GSP file like this one, and then when we actually perform, we actually should actually see correct. Yeah, so basically the list. Yeah, so we're actually trying to find all the payments less than 25. Okay, so let's actually try that. So we probably have a different the result because we didn't have a credit card. Okay, so list some payments. I'm gonna just do this. Oh, we didn't create the this GSP file. Okay. So we have to create this list sum payment GSP file. Okay, in the view here, payment and GSP file. Name of it is this, finish, and then we're gonna just copy this guy, and here it will just display each payment like this. Save. Then if I go back, now if I try this, and okay, so in this case we have only one payment, okay, because we didn't have a credit card. The payments saved, okay. All right, so that worked okay. All right, so that is the single table strategy. Now we're going to actually set payment to use the join class or the table per subclass strategy. So in that case, you have to actually specify like this. So we go to the payment, okay. So this time we're going to actually change the the credit card domain class as well. So let's go to domain class. Domain class of payment. This is a parent class. So you specify in the parent class, okay? So we're going to actually specify table per hierarchy is going to be false, okay? And let's actually change the credit card payment class as well. So credit card payment domain class is going to be like this. Oh, it did it. I did change it. Okay, credit card and PayPal. Yeah, I don't know why that didn't work. Okay, and oh, did I change the? Okay, so looks like the credit card is supposed to work. Okay, all right. So that is so here we are going to use the join subclass strategy. Okay, and we are gonna restart the application, and we're gonna actually see this time multiple tables. Okay, run as. Okay, and we're gonna go to we're gonna create the payment. So here, let's go to. Okay, so now let's take a look at the database. Now you can see, we have we have a payment table which contains just the amount. This is the field from payment parent class. Now we have a PayPal payment table which has its own field amount. Oh, I'm sorry, PayPal run, and this is the account number of PayPal. So account number is from PayPal subclass, and then we have a credit card. So let's clear and credit card payment, and if I run it, then I can see, yeah, so somehow the data, the table is created, but somehow the data is not being actually entered correctly, okay? But you actually see the point how things work. Things worked, right? Okay. All right, so that is inheritance strategy. Okay, so I believe that's the end of the presentation. Okay, so let me just say